We are now going to cover section 2.8, function, operations, and composition. You were introduced to functions in 2.6, and now we're going to work with the operations of them: addition, subtraction, multiplication, and division. We're also going to cover composition of functions. This comes from covering examples 1, 2, 3, 5, and 6 in your ebook. The key term is composite function or composition. As far as the operations go, if you have two functions, putting all of this in plain language, you can add those two functions together, you can subtract one from the other, you can multiply the two functions, and you can divide them. So given two functions down here, we're given that f of x is equal to x squared plus 1, and the function g of x is equal to 3x plus 5. And you're asked to find each of the following. First, they want us to add them. The definition says that if I read this right here, this is the way we would write it, f plus g of x, it simply means take f of x and add it to g of x. So in this case, we have a value, f plus g of 1. So this simply means that we are going to take f of 1 and add it to g of 1. So we substitute 1 in. Remember, f of x is x squared plus 1. So this would be 1 squared plus 1. There's f of x, or f of 1 in this case, plus g of 1. So we would take and substitute the 1 in to g. So there is your f of 1 plus your g of 1. 1 squared plus 1, 2. 3 times 1, 3 plus 5, 8. And you will have 10. So what we're saying is that f plus g of 1 equals 10. The same applies with subtraction. Our directions simply say this. If I have the notation f minus g of x, it means to take f of x and subtract g of x. So I have f of x, I'm going to subtract g of x, but in particular, it's going to be f of negative 3 minus g of negative 3. So let's write that first. F of negative 3 minus g of negative 3. So I'm going to take the negative 3. I want to take f of negative 3. So that would be a negative 3 squared plus 1. Notice the negative 3 is being squared because it is what's going in place of the x. That x is being squared. Plus 1. Minus the g of negative 3. Now always be cautious when there's a minus. I'm going to put a parenthesis here just to make sure that I handle that minus sign correctly. Sometimes you have to distribute the minus. So g of negative 3 would be 3 times negative 3 plus 5. So now I have negative 3 squared is 9 plus 1 minus 3 times negative 3 is negative 9 plus 5. 9 plus 1 is 10 minus negative 9 plus 5 is negative 4. So it kind of helps me by having the parentheses. I see it's minus a negative. It becomes plus a positive. So that's 10 plus 4, which is 14. Now this is equal to this, which equals this, which equals this. So I'm going to go back until I show finally f minus g of negative 3 is 14. We can do it with multiplication. On functions, here we have f times g of 5. So if you read that, f times g is the notation. It means take f of x times g of x. Ours is going to be a 5. F of 5 times g of 5. So if you do that, we put the 5 into the function of f. So that's going to be 5 squared plus 1 times, I'm going to have to use my parentheses here, g of 5 would be 3 times 5 plus 5. So now we have 5 squared is 25 plus 1 is 26. 3 times 5 is 15 plus 5 is 20. And 26 times 20 is 520. Looking at D on example 1 is the division. So notice we've done addition, subtraction, multiplication, and now let's practice a division. F over G, or F divided by G of X, means F of X divided by G of X. And in our case, it's of 0. So it's going to be F of 0 divided by G of 0. So this equals F of 0 divided by G of 0. Substituting the 0 into the function f, I have 0 squared plus 1. Substitute the 0 into g, I have 3 times 0 plus 5. I'm going to go across right here. 0 squared is 0, plus 1 is 1. 3 times 0 is 0, plus 5 is 5. So f divided by g of 0 equals 1/5. If you would like, in your ebook, there's a You Try It button next to example 1. You can click on that, and it will give you an example like this to work, and you can go through that process. If you would like to pause the video and do that, you can. Let's start with example 2 now. Example 2 says using operations on functions. Again, it's going to give us a function f of x equals 8x minus 9. It gives us g of x equals the square root of 2x minus 1. Find each function in A through D. So again, we're dealing with the operations, addition, subtraction, multiplication, and division. But I want you to see the difference. In example 1, we had values here, but now in example 2, notice how they all have an x. So we're changing just a little bit here to know how to handle if you have a value or if you just have an x. So if I have f plus g of x, that is equal to f of x added to g of x. And because I don't have a value, that's what I'm really going to do. I'm going to take f of x, which is 8x minus 9, and add it to g of x, which is the square root of 2x minus 1. Notice there are no like terms. That's it. You added the two functions together. The same applies here. F minus g of x means f of x minus g of x. F of x again, let me put a line here to separate these, is 8x minus 9 minus g of x, which is the square root of 2x minus 1. Again, there are no like terms. That's as much as I can do. Let's practice this C. F times g of x is equal to f of x times g of x. So I'm going to take f of x, which is 8x minus 9, times g of x, which is the square root of 2x minus 1. Now you could distribute that, but it's not going to create any like terms, so I can just leave my answer as is. The last part is D. It's the division. Again, we've practiced addition, subtraction, multiplication, and now division. So I have f divided by g of x, which means f of x divided by g of x. And f of x is 8x minus 9, and g of x is the square root of 2x minus 1. If you would like to practice an example of this, you can with your You Try It button. They give you f of x is 7x plus 3, g of x is 4x minus 5, and ask you to find each operation. I would like to do 2 of these with you. I want to work these 2 on this particular example. So here is f of x, here is g of x, and I want to do f minus g of x, which means f of x minus g of x. I want to point out the caution about when there's a minus sign. So let's do this operation. So f of x is 7x plus 3 minus g of x, which is 4x minus 5. Watch out. Big time issue here. It's not minus 4x. It's minus that whole function. So earlier I had made mention about the importance of parentheses. So what we want to do, if you want to, you can say that one is f of x minus the g of x. Anytime there's a minus, you want to be cautious. I really don't need this parenthesis. I'm going to withdraw it again. But now this is where I need it. It's minus 4x. And then a minus times a minus becomes a plus 5. So there's your caution. That's why I want it to work. Up here with the minus, it was just a radical, so it didn't show up so much as the more common problems like this You Try It problem. Now I can combine like terms. 7x take away 4x is 3x. A positive 3 and a positive 5 is a positive 8. Let's do one more. I wanted to do the f times g of x. Which means f of x times g of x. So f of x again is 7x plus 3 times g of x, 4x minus 5. So you see with this product, with the radical it was a little bit simplified. This you really need to FOIL. So let's FOIL this out and clean it up. So your first 28x squared, your outer 7x times negative 5 is negative 35x, your inner 3 times 4x, and your last 3 times a negative 5 is a negative 15. You might be working ahead of me, so you want to go ahead and put these together. You have 28x squared minus 23x minus 15. So it's simplified, you combined, you pulled it out, you combined your like terms, and gave me the simplified version of that answer. We're going to do one more example that deals with the operations. So let's look at that. Example 3. Evaluate the following, but this time I've given you a picture graph. Here's f of x, there's g of x, a table with f of x and g of x, and then of course here are the equations. In this one they want you to approach it by taking A and applying all of these to A, to each one of these operations, and then they want you to go to B and apply each of these operations, and then to C. So let's do that. Let's look at A, f plus g of 4. So remember, f plus g of 4, call this the first one we're going to do. means f of 4 plus g of 4. And you're going to say, what do I do to get f of 4 looking at this? Remember, this is your f of x. So you're saying x is 4. So f of 4 means find the y that goes with the 4. So on f of x, we want to go to where x is 4, 1, 2, 3, 4, and find the y that goes with it, which is up here at 9. When x is 4, y is 9. So f of 4 is 9. Now you can find g of 4. This is your g of x. You want to go to where x is 4 and find the y that goes with it, and that is 2. So f of plus g of 4 means f of 4 plus g of 4. In this case, that's 9 plus 2, which is 11. Let's look at number 2, which is f minus g of 2. That means f of 2 minus g of 2. So we need to find f of 2, go to where x is 2, and find the y that goes with it on the function f. X is 2, and the y is 5. Is that correct? Okay. Oh, it's negative 2. Excuse me. Let me fix that. So f of negative 2. Negative 1, negative 2, and find the y that goes with it. Let's go down and touch that line. That's negative 3. Minus g of negative 2. All right, here's g. We want to go to where x is negative 2. And notice g doesn't even exist over here. G starts right here where x is 0. So what we have is no definition of it right there. So that's undefined at negative 2. So that makes the whole answer undefined. You can't say negative 3 minus undefined. It's just undefined. Let's look at f times g of 1. That means f of 1 times g of 1. I think you've got the hang of it now. So f of 1, let x be 1, and that would give me 3. G of 1 is 1. So 3 times 1 is 3. Let's look at the fourth one. F over g of 0 means f of 0 divided by g of 0. So we go to f of 0 where x is 0, f's function y is 1, over g of 0, when x is 0, y is 0 for g. We have 1 over 0. Do you remember what that is? That is undefined. Remember, you can never have a 0 in the denominator because of the definition of a fraction. This is how many pieces make the whole. If there's 0 pieces that make the whole, can you have 1 piece out of nothing? And that's impossible. It's undefined. So we used the graph. We went to the x value, found the y that went with it, and applied it to the operation. Let's look at the b part. On the b part, it's a table. So we're going to go through the same steps. The first one is to do f plus g of 4. Now the way you read this table, this is your x value. So if x is negative 2, then f of negative 2 is negative 3. G of negative 2 is undefined. So this is the x, this is the y on f. This is the x, this is the y that goes with it. If x is 0, the y that goes with it on the function f is 1. So the point 0, 1. For g, when x is 0, y is 0. When x is 1, then y is 3 on the function f. If x is 1, the y that goes with it on the function g is 1. So it's just like the graph. These are your y's here that go with the x. So I want f of 4 plus g of 4. F plus g of 4. So I go to where x is 4, f of 4 is 9, g of 4 is 2. And notice it's the same here. This is the table, this is the chart of what we just went through. So we did it visually, and here it is written out, the y values that go with the particular x's that we have already processed. So let's look at number 2. We'll go through those steps. F minus g of negative 2 means f of negative 2 minus g of negative 2. So we go to where x is negative 2. F of negative 2 is negative 3. G of negative 2 is undefined. And again, undefined, undefined. F minus g, table and graph. So we go through the same steps. You read the table. So 3, we're doing f, g of 1. That means f of 1 times g of 1. X is 1, so f of 1 is 3. G of 1 is 1. I get 3. The fourth is f over g of 0. F of 0 is 1. G of 0 is 0. Anything over 0 is undefined. So notice the duplication. We just used a graph and a table, but they were the same values. These reflect the same two graphs. Last is the C part, and actually we're going to get all the same answers again, but in this one they give you the actual equations. 2x plus 1 is this line when you graph it. The square root of x is this half of a parabola. So now we're just applying the same things again. The first part is f plus g of 4. If we're just given the equations, that means f of 4 plus g of 4. We're going to take the 4 and put it in the equation. G of 4 would be the square root when we substitute it in. Okay, so that gives me 2 times 4 is 8, plus 1 is 9, plus the square root of 4 is 2. There's your 11. Number 1, number 1, number 1. So all three of these things reflect the same graph. Do number 2, substitute in f minus g of negative 2 means f of negative 2 minus g of negative 2. So we're going to take negative 2, let me cover this up a little bit so we don't see that other work. Alright, g of negative 2, f of negative 2, 2 times negative 2 plus 1, there's your f of negative 2, minus g of negative 2, the square root, let's put your negative 2 in there. So 2 times negative 2 is negative 4, negative 4 plus 1 is negative 3, minus the square root of negative 2. That is imaginary. It's undefined. I cannot take the square root of a negative 2. So this is undefined. F, G of 1 means f of 1 times g of 1. Running out of room. Let me make some marks here, okay? Alright, remember we're just using the equations, so let me cover up this other work we've been doing. A lot of work. Needed more room, didn't I? So that would be f of 1 times g of 1, put the 1 in there. 2 times 1 is 2, plus 1 is 3. The square root of 1 is 1. That equals 3. So you just substitute them into each of those equations. This is a good stopping point. We've completed the examples that cover the operations of functions, addition, subtraction, multiplication, and division. The next part is getting into compositions. If you would like to turn to example 1, 2, and 3, and you want to go ahead and do some practice work, you can use your ebook, and you can find these problems, work these problems from your ebook, and refer to the solutions in the back to make sure you have it correct, and talk to a teacher if you need any help.